Data and signal in physical layer. One of the major role of physical layer is to transfer the data in the form of signals through a transmission medium. It doesn't matter what data you are sending. It can be text, audio, image, video, anything. Everything is transferred in the form of signal. This happens because data cannot be sent as it is over a transmission medium. It must be converted to a form that is acceptable by transmission medium. That is, signals are what a transmission medium carries. So, let us try to understand what type of signals are these. Analog and digital. Both data and signal can be represented in form of analog and digital. Analog and digital data. Analog data is continuous data that keeps changing over time. For example, in an analog watch, hours, minutes and seconds hands keeps moving, so you infer the time by looking at it. It keeps changing. On the other hand, digital watch shows you the discrete date such as 11:30 a.m. or 6:30 p.m. etc. has a particular moment of time. So this is the difference between analog as well as digital data. Now what is analog and digital signal? Similar to date data, a signal can be analog or digital. An analog signal can have infinite number of values in a given range. On the other hand, digital signal has limited number of values in a given range. The following diagram which you see in the slide explains or depicts what is analog and digital signal. In this slide, let us try to understand what is periodic and non-periodic signal. A signal is said to be periodic if it repeats itself after a regular interval of time. For an example, assume there is a sinusoidal signal and the amplitude and the frequency of the signal remains same for every n intervals, then it is called as periodical signal. Whereas in a non-periodical signal which do not repeat itself in a fixed time period, I mean there is no constant time period with respect to non-periodical signal. Now when we are talking about periodical signals, analog signals can again be classified into simple as well as composite. What is a simple analog signal? A simple analog signal can be represented in the form of sine wave. A sine wave is as shown in the diagram below. A simple analog signal is smooth, consistent and continuous. As you can see in the diagram that the arch above the time axis t and is followed by the similar arch below the time axis. So the parameters of a simple analog signals can be peak amplitude, that is the highest intensity of the sine wave remains constant. Frequency and the period is the amount of time the signal takes to complete one particular cycle, whereas the frequency is number of cycles in 1 second. And the third one would be phase. Phase refers to the position of sine wave relative to time 0. For example, in a sine wave is at its highest intensity at time 0 than phase value. So this is with respect to simple. Now let us try to understand what is a composite analog signal. Unlike sine wave, which is smooth and consistent, composite analog signals or waves are not smooth and consistent, which means that the arch above the horizontal line, that is time axis, doesn't necessarily be the same below the time axis. You can imagine them as a group of sine waves with different frequency, amplitude and period. Bandwidth, the range of frequency in composite signal is called as bandwidth. For example, if a composite signal contains wave with a frequency ranging from 2000 to 4000, then the bandwidth would be 4000 minus 2000, that is equal to 2000 hertz, band 2000 hertz. So that's all about simple and composite analog signals. Frequency of a sine wave is the number of complete cycles that happens every second. So we can say that frequency is equal to 1 by t, or t can be calculated using 1 by f. So this is a simple calculation. Frequency, now just to give you an example, frequency used to measured in cycles per second. This graph will give us a clear comparison between amplitude and different frequencies. Now in the first and the second graph, the amplitude and the phase for both the graph remains the same. For example, in one particular second, they have calculated the amplitude uh, and amplitude that remains the same, whereas in both the graphs, in one particular second, the cycle is, in the first graph the cycle is repeated 12 times, whereas in the second graph the cycle is repeated only 6 times. So in this case, the frequency in the first graph is 12 hertz, whereas when it comes to the second graph it is 6. So uh, so the amplitude in both the graphs remains the same, that is in 1 second the highest amplitude remains the same, but the frequency here has changed. This is an self-explanatory um, table which helps you understand period and frequency and its units. Nothing to be explained specifically in this. Let us try to understand one more concept, that is phase, uh, with respect to sinusoidal wave. Now, when we talk about a wave, a full cycle of a wave, maybe half of it is above the zeroth line or the horizontal line, and half of them is below the horizontal line. It totally forms a 360-degree circle. So a phase is always measured in degrees or in radians with respect to its relative position to 0. Let us look at time 0. Let us look at the diagram. It is a little complicated to understand. Now you have three graphs over here. Okay, the amplitude and the frequency of the graph remains the same, but there is a variance amongst the phase. If you see the first graph, the starting point of the sinusoidal wave is at 0th position and is going up, whereas in the second graph the the starting point is in the 90th position and it is going down, whereas in the third graph it is in the negative side and it is again going down. So if you are considering one particular wave as a circle, then the difference between the first wave and the second wave would be 90 degrees, whereas the difference between the second diagram and the third diagram would be again 90 degrees. And if you are comparing the first diagram and the third diagram, then the difference would be approximately 180 degrees. So in short, phase is not a parameter, but it helps us to understand the phase difference or the phase shift. Wavelength. The wavelength is the distance a simple signal can travel in 1 second. Or in other words, wavelength distance between the corresponding points of two consecutive waves. Now the corresponding points refers to two points or particles in the same phase, that is, point that have completely identical fractions of their periodic motion. Let us try to get the formula to define wavelength. Wavelength is usually denoted by a Greek letter lambda. It is equal to the speed v, or in this case as per your textbook, c, of the wave in the medium divided by its frequency. So lambda equals to c by f, where c stands for speed and f stands for the frequency. We would have heard about this word bandwidth a lot of time. Let us try to understand what is bandwidth. In simple concepts, the range of frequency contained in a composite signal is its bandwidth. The bandwidth is normally a difference between two numbers. Let me try to give you an example with respect to signal. Now, when I'm talking, my frequency of my voice may vary from 300 to 3100 hertz. So the range or the bandwidth would be 3100 minus 300. That would be approximately 2800. So the bandwidth would be 2800. So each of these bandwidth can be calculated, is calculated between these two numbers. That is the second point. So a signal can generate a bandwidth. A device like phone, etc., or a speaker can also generate a bandwidth, can have its own bandwidth, as well as channels. Different type of channels also can have different bandwidth.